G'day guys, and welcome to Mastering the Multiplication Table, Strategies for Mastering Multiplication Facts. Here we have our times tables, our multiplication table in front of us, going from 1 times 1 to 12 times 12. This can be sometimes very daunting and give students anxiety because there are so many numbers on the table. However, it's pretty easy if you know the strategies. And today I'm going to take you through every single strategy that you need to know to be successful at mastering your multiplication facts. Our first strategy when multiplying by 1 is saying to ourselves, when I multiply by 1, the product stays the same. 1 times 6 equals 6. 1 times 8 equals 8. One group of 6 is equal to 6. So all we're saying is when we multiply by 1, the product stays the same, or the number at the end of our number sentence stays the same. 1 times 6 is 6. 1 times 8 is 8. 1 times 9 is 9. One group of 2 is 2. One group of 3, or 1 times 3 is 3. Anything multiplied by 1 remains the same. The product stays the same because we're only talking about one group. When we're looking at another rule or another law is the commuting law. So what do we mean by this? Commuting means to move around. So 1 times 5 is the same as 5 times 1. The group stays the same. One group of 5 is the same as 5 groups of 1. If we have a look at our model, we can see that the group has been rotated. It's gone from being horizontal or flat to being vertical, upright. So we can see that 1 times 5 is the same as 5 times 1 because the group stays the same. The product will always be 5. If we look at a second example, we can see that 2 times 5 equals 10. 2 groups of 5 is 10, and 5 times 2 is 10. 5 groups of 2 is 10. We can see that the product stays the same. So the idea of commuting means that the numbers can be in any position. 2 and the 5 can be at the start or the front. 2 times 5 or 5 times 2, and the product will stay the same. So what does that mean for our multiplication table? Well, if we look at 5 times 4 equals 20, we can also see that 4 times 5 equals 20. So when we commute and we change the numbers around, the product stays the same. So roughly, we only have to know half of our multiplication table, because if we know 5 times 4, we know 4 times 5. So what does that mean? What does that look like in relation to the ones times tables? If we have a look at the table, we can remove the following numbers or the following multiplication facts. We can see that 1 times 4 is the same as 4 times 1. Let's have another look. 4 times 1 and 1 times 4 are 4. So we can remove all of those numbers. Our next strategy that we're looking at is whenever we're multiplying by 2, we're doubling. 2 times 6 equals 12. 2 groups of 6 is 12. If I double 6, I get 12. 6 plus 6 is the same as saying 2 times 6 because we are repeatedly adding 6 and 6 again. So anything that is multiplied by 2 is a double. If I double 6, I get 12. How does this look on the multiplication table? Well, if we look at our 2 times tables, we can see that anything multiplied by 2 is a double. So we can remove these multiplication facts. If we move on to our next rule or our next little strategy that we can use, I like to use the strategy of skip counting when I'm multiplying by 5s. 5 times 6 is 30. So skip counting by 5 6 times results in 30. 5, 10, 15, 20, 25, 30. If I skip count by 5 6 times, I get to 30. If I look at my second example, 5 times 4 equals 20, I can see if I skip count by 5 4 times, I get to 20. 5, 10, 15, 20. So that is a little rule that I use when I'm multiplying by 5s. I think to myself, I'm going to skip count. Once again, if we go back to our table and we look at our 5 times tables, and we can see that we're skip counting by 5s, that's our strategy that we're using, we can remove these numbers from the multiplication chart. There we go. Our next strategy is multiplying by 10. Here we go. So whenever we multiply by 10, the number we are multiplying by, the tens column changes to that number. This is a little trick that I use. 4 times 10 equals 40. I replace the 110 in 10 and I change it to 4 tens because 1 times 4 is 4. So 4 times 10 equals 40. 9 times 10 equals 90. 8 times 10 equals 80. 2 times 10 equals 20. If I change the tens column, I know that I can solve multiplication facts involving 10. So how does that look again on our table? So we're going to knock out another couple of lines. There we go. The horizontal and vertical lines have been knocked out. So we've got our first 4 strategies. Let's have a look at our 5th strategy. Our 5th one is when multiplying by 11, we change both the tens and ones digit. 2 times 11 is 22. 5 times 11 is 55. 8 times 11 is 88. This works the majority of the time, and you'll find later on that there are certain exceptions to this rule. So if we go back to our chart, we can see that we can knock out the 11 times tables now. Let's review. When we're multiplying by 1, we are multiplying 1 by a number by itself. Okay, so what we are saying is 1 times 8 equals 8. So anything multiplied by 1 is itself. So let's knock out those numbers. If we look at 2 times tables, we are doubling. 2 times 4 is 8. We are doubling 4 to make 8. We can also think of our 2 times tables as repeated addition. Is 4 plus 4 equals 8. If we are multiplying and we're saying 2 times 5, we're saying 5 plus 5, or double 5 equals 10. So we knock out those numbers. Once again, my skip counting strategy for multiplying by 5s, I use skip counting, and we can knock out these numbers. When I am multiplying by 10, I change the first digit and I say to myself, 2 times 10 equals 20, 3 times 10 is 30, 4 times 10 is 40, 5 times 10 is 50. And I can knock out these numbers here. When I look and I'm looking at my 11 times tables, I can say to myself, I change both the tens and the ones digit. 3 times 11 equals 33. 4 times 11 is 44. 5 times 11 is 55. 2 times 11 is 22. 1 times 11 is 11. And I knock out those numbers. I knock out those multiplication facts. All right, part 2. An extension of multiplying by 2 is multiplying by 3. When I think about my 3 times tables, I say to myself, 2 groups of 4 plus 1 more group of 4 equals 3 groups of 4. 2 times 4 equals 8. And then 1 more group is 1 times 4 equals 4. So I know that 8 plus 4 must equal 12. 3 groups, I've got 3 groups of 4 equals 12. So the first thing I think about is my 2 times tables, and then I add 1 more group. 2 times 4 is 8, and another 1 times 4 is 4, so 8 plus 4 must equal 12. So if we go back to our chart, we can take off these numbers. The multiplication facts that have been eliminated are in the blue. All right, let's have a look at anything multiplied by 4. When we look at multiplying by 4, we can see that multiplying by 4 is an extension of multiplying by 2. It's a double-double. Whenever I multiply by 4, I'm thinking double-double. So if I double 6, I get 12. But if I double 12, I get 24. So therefore, 4 times 6 must be 24. It's a double-double. So whenever I multiply by 4, I think about double-double. That's my rule. All right. So we can see that our multiplying by 4 is a double-double, so we can remove those multiplication number facts from our board. There we go. Part 3, square numbers. So I've highlighted some numbers here that we have left. Okay, if we look at the numbers down in the diagonal, 36, 49, 64, 81, 144, we can see that these are square numbers. We can see 36, 49, 64, 81, and 144 are square numbers. So the arrangement that I like to think about is a square. 6 rows of 6, 7 rows of 7, 8 rows of 8, 9 rows of 9, 12 rows of 12. If we have a look at square numbers, we can see that we have arrangements that look like squares. 6 rows of 6 in each, 6 times 6 is 36. 7 rows of 7 in each, 7 times 7 is 49. 8 rows of 8 in each, 8 times 8 is 64. These are square numbers. So what we can do now that we see those arrangements, we can eliminate those as well. What's left? Let's have a look at what's left. If we have a look at what's left, we can see we have the 9 times tables. So when we look at 9 times, I think to myself 10 times and then one group less. So 10 times 6 is 60, one group less, one group of 6 less is 54. 10 times 7 is 70, one group less of 7 is 63. 10 times 8 is 80, one group less of 8 is 72. And we know that the commutative rule comes in as well. So we know that 9 times 6 is the same as 6 times 9, 9 times 7 is the same as 7 times 9, 9 times 8 is the same as 8 times 9. And we can eliminate those. The 7 that are left. Okay, so we have 7 numbers that are left, 7 multiplication facts that are left. We have 6 times 7, 6 times 8, 7 times 8, 12 times 6, 12 times 7, 12 times 8, 12 times 9. These are the ones that I like to learn. Okay, these are the ones that I like to practice. The other multiplication number facts you can just know from the rule. Okay, if you think about all the rules that we have, the strategies that we've gone through, if you apply those strategies, they come to you, then multiplication number facts will come to you a lot more easily. Okay, let's go back just for a second, which eliminates the purple, eliminates all the other numbers. So in summary, let's have a look at our multiplication rules. Anything multiplied by 1 is itself. 1 times 8 is 8. Whenever I think about multiplying by 2, I'm thinking about doubling my number. Whenever I think about multiplying by 5, I skip count by 5. Whenever I'm multiplying by 10, I think about changing that 10's digit. 2 times 10 is 20. Whenever I'm multiplying by 11, I change both digits. Whenever I'm multiplying by 3, I think of my 2's facts and then one more group. When I'm multiplying by 9, I think to myself, one group less than 10. And then we have the 7 remaining multiplication facts to learn. So this is just a quick summary of all the strategies that you can use to develop your understanding and your knowledge of the times tables. So if you apply these rules, you should be able to learn your multiplication facts pretty easily. So what I want you to do is, if you have any problems with any of these strategies, go back and watch the video. Slow down, go back and watch the video. Try to think about what it is that I'm trying to say. And start off by practicing our 1s, 2s, 5s, and 10s, and then move on to our other multiplication strategies.